Then see the question number 23. Yes, question number 23, that is given as what? There is a one tank circuit. Okay, given that there is one tank circuit. Tank circuit. Yes, this is my, let us say this is my tank circuit. Okay, so this is my tank circuit. This is inductance, this is capacitance. And given that that temperature coefficient of dielectric material. Yes, temperature coefficient of dielectric material that is used in the capacitance, that is how much? Alpha epsilon r is equal to 6 part per million, 6 part per million per degree Celsius. Okay, so this is given. Now asking that what is the temperature coefficient of resonant frequency at which this tank circuit resonate. Okay, tank circuit oscillate, this resonate at this resonant frequency. Then what is the temperature coefficient of this resonant frequency? Okay, so now let us see. As we know the capacitance. What? Capacitance in case of temperature is given as what? C equivalent. C equivalent is equal to what? C equivalent is equal to C into 1 plus alpha epsilon r into delta T. Okay, so this is for what? Capacitance in case of temperature, where alpha, where what? Where temperature coefficient of capacitance is given as 1 by C dc by dt. Okay, dc by dt. Similarly the temperature coefficient, similarly for what? Similarly for resonant frequency. Yes, for resonant frequency, if you see for resonant frequency fr. Okay, so for resonant, what? For resonant frequency fr is equal to fr naught into 1 plus alpha 1 plus alpha fr 1 plus alpha fr delta t. Okay, so where resonant frequency fr, alpha fr is nothing but 1 by fr into dfr by dt. Okay, our main target is what? For this, yes, we want to find what? Resonant frequency, that temperature coefficient of resonant frequency alpha fr. Okay, so for that, first of all, see this resonant frequency fr is equal to what? 1 by 2 pi square root of lc, square root of lc. This we know very well, resonant frequency. Now there is a term dfr by dt. Okay, so now we will calculate this step. Okay, so let us now differentiate this resonant frequency with respect to what? Temperature. Dfr by dt, dfr by dt is nothing but 1 by 2 pi square root of l. Okay, square root of l into d by dt of what? 1 by square root of c. Okay, square root of c. Now see here, dfr by dt is equal to what? Is equal to 1 by 2 pi square root of l. Okay, now differentiate this d by dt of 1 by square root of c is what? This is nothing but minus 1 by 2 2c 1 by 2c root c 2c root c. Okay, so how it came? See here, this is 1 by square root of c d by dt of what? C to the power minus 1 by 2 is nothing but what? Is nothing but minus 1 by 2 into c to the power minus 3 by 2, and take it in denominator, it become positive. So this is nothing but minus 1 by 2 into c to the power plus 3 by 2, which is nothing but what? Which is nothing but minus 1 by 2 c root 2. Okay, so this is what? Differentiation of capacitance. Yes, 1 by square root of c. Differentiation of 1 by square root of c is nothing but minus 1 by 2 c root c. 2 c root c. Okay, so c root c into dc by dt. Okay, dc by dt. So now what we will do, just take this root c outside. What we will get here, dc dfr dfr by dt. Dfr by dt is how much? Dfr by dt is equal to 1 by 2 pi 2 pi square root of lc, square root of lc, and inside what is there? Minus minus 1 by 2, what, 2c into dc by dt, dc by dt. Okay, so now see here, dfr by dt, dfr by dt is equal to, this is what fr, this is what fr, this is minus 1 by 2c, minus 1 by 2c. Okay, so let us see this, minus 1 by 2, minus 1 by 2 into 1 by c, dc by dt, dc by dt. So now dfr by dt, dfr by dt is equal to, what is this, fr? So this is my minus 1 by 2 fr into what is this? This is nothing but alpha epsilon r. Okay, so take this fr this side, this is nothing but 1 by fr, 1 by fr into d fr by dt is equal to what? Is equal to minus 1 by minus alpha epsilon r by 2. Yes, what is this? 1 by fr by dfr by dt is nothing but alpha fr. Alpha fr is equal to minus alpha epsilon r by 2. Yes, now just put this value, minus alpha epsilon r is equal to what? Minus 6 part per million per degree Celsius divided by 2. So therefore we got alpha fr is equal to minus 3 part per million per degree Celsius. This is what? This is the temperature coefficient of what? Temperature coefficient of resonant frequency. Yes, temperature coefficient of resonant frequency, that is alpha fr. So this is what? Alpha fr is equal to minus 3 part per million per degree Celsius. Yes, this is the answer. So the answer for this is what? A. Okay, A is the answer for question number 23. Okay, so this is the process of doing this. Okay, for temperature coefficient of resonant frequency. This is my LC circuit and it is oscillating at this resonant frequency. Okay, so that's all for this. So thank you very much. Okay, so okay, bye.